In this DaVinci Resolve tutorial, I'll show you how to create your own custom video transitions and place them in the effects library for use in any project. We'll create this falling tiles transition. It's easiest to start with an existing Fusion transition. Open the effects library and select the Video Transitions category. Then scroll down on the right to the Fusion Transitions subcategory. Grab the cross-dissolve transition and place it over an edit point in the timeline. Select a transition, right-click, and choose Open in Fusion page. Delete the cross-dissolve node. Media in 1 contains the outgoing clip, and Media in 2 the incoming clip. I'll rename them to outgoing and incoming respectively, so it's easier to keep track of which is which. The outgoing clip will break apart into 4 tiles that will tumble down to reveal the incoming clip beneath, so it needs to be superimposed over the incoming clip. Disconnect the outgoing node from Media Out 1 and connect the incoming node instead. With the incoming node selected, insert a multi-merge node. Notice that the incoming node is connected to the yellow background input of the multi-merge node. This means that other nodes connected to the multi-merge node will be superimposed on top of the incoming clip. To create the 4 tiles, 4 instances of the outgoing node are needed. Select the outgoing node and press Command-C, Control-C in Windows to copy it. Paste 3 copies of the node by pressing Command-V, Control-V in Windows 3 times. Connect one of the outgoing nodes to the multi-merge node. This will become the upper left tile. We'll use rectangular masks to create the tiles. Connect a rectangle mask node to the outgoing node. This will be the upper left tile, so it needs to be positioned in the upper left. Here's how the coordinate system in DaVinci Resolve works. The x or horizontal axis starts at 0.0. This is the leftmost position. The center is 0.5 and the rightmost position is 1.0. The y or vertical axis starts at 0.0, the bottommost position. The center is 0.5 and the topmost position is 1.0. Right now the rectangle mask is positioned in the center of the frame, that is, center x and y are both set to 0.5. To position it in the upper left, set center x to 0.25 and center y to 0.75. I'll rename the rectangle mask node to upper left. To create the upper right tile, connect one of the other outgoing nodes to the multi-merge node. Again, connect a rectangle mask node. Set center x and y both to 0.75. I'll rename the node to upper right. For the lower left tile, set center x and y both to 0.25. And for the lower right tile, set center x to 0.75 and center y to 0.25. All the tiles are in place. Now to make them tumble, we'll start with the upper left tile. Select the outgoing node for the upper left tile and insert a transform node. The tumbling effect will of course require animation, which normally would require us to use keyframes. But when creating a transition like this, one that's to be used over and over in various situations, keyframes should not be used. The reason is that transitions tend to be shortened or lengthened to meet the requirements of a particular situation. If the transition animation is manually keyframed, the animation will be static in length and will not shrink and expand as the length of the transition is changed. Not good. To get around this seemingly impossible situation, we'll use modifiers. Modifiers will add keyframes, but Resolve will do all the hard work of managing them for us, shortening and lengthening the animation as the transition is shortened and lengthened. To have the tile tumble downwards, we'll begin by applying an XY path modifier to the center XY parameter pair of the transform node. Right-click on the center label and select Modify with XY path. Click on the Modifiers tab at the top of the inspector. Remove the keyframe from the Y parameter. The tile will be falling down, moving vertically, so the X parameter can be ignored. Apply an Animation Curves modifier to the Y parameter. Right-click on Y and select Modify with Anim Curves. The tile's moving upwards. We want it to move downwards. The Anim Curve modifier controls are visible in the inspector. Place a check mark and invert to reverse the direction of the tile. Now, instead of up, it'll go down. The mirror option while we're here will cause the animation to play twice, the second time in reverse. It's still not quite right. The tile's not visible on the first frame. To fix this, double-click on Transform 1 Center XY Path 1 at the top of the inspector to expand the modifier controls for the XY path modifier. Set Y of center XY to 0.0. The tile's falling behind the lower left tile, but that's not a problem, as that tile will also be falling. For a more realistic effect, the tile should start off slowly and speed up as it falls. This can be done with easing. Expand the modifier controls for the Anim Curves modifier. Select Easing from the Curve dropdown. Set in the cubic. Take some time on your own to experiment with the other options in this list to see what they do. We only want to ease in, not out. If we were to add easing to out, the tile would slow down as it reaches the bottom, which wouldn't make sense. Set up the XY path and Anim Curves modifiers on the other three tiles in the exact same way. All tiles are falling together, so it's not a tumbling effect as yet. We'll apply an Animation Curves modifier to the angle parameter of the transform nodes. This will change the angle of the tiles as they're falling, creating the tumbling effect and allowing each tile to stand out from the others. Let's start with the upper left tile. Select a transform node and apply an Anim Curves modifier to the angle parameter on the Tools tab of the inspector. It's spinning too fast. Click on the Modifiers tab and expand the modifier controls for the Anim Curves on Transform 1 Angle modifier if they're not visible. It's important to understand how the controls here work, so bear with me. The scaling section controls how much of the animation is played or completed during the clip. Scale is set to 360. Because the Anim Curves modifier is being applied to the angle parameter, this means 360 degrees, or one complete revolution, which means the tile will complete one revolution by the time the playhead reaches the last frame of the clip. For other parameters, scale will usually have a default value of 1.0. If scale is set to 720, double 360, the tile will complete 2 revolutions by the end of the clip. If tile is set to 90, 1/4 of 360, the tile will only complete 1/4 of a revolution by the last frame of the clip. Offset advances the animation forward, so it begins before the first frame of the clip. For example, if set to 90, the tile would have already completed 1/4 of a revolution on the first frame. In other words, the animation will begin 1/4 of the way through. Again, 90 is 1/4 of 360. And if set to 180, 1/2 of 360, then half a revolution would already have been completed on the first frame, or, to put it more simply, the animation begins halfway through. Clip low ensures the output values of scale and offset never go below 0, and clip high ensures they never go above 360. The timing section controls the speed of the animation. When timescale is set to 1.0, the animation will last the full duration of the clip. If doubled to 2.0, the animation will complete halfway through the clip. In other words, the animation will run twice as fast. If set to 0.5, the animation runs at half its normal speed, so it's only half completed by the end of the clip. Time offset delays the animation when its value is greater than 0. If set to 0.5, the animation won't begin until the playhead's halfway through the clip. If set to 1.0, the animation will begin on the last frame of the clip. So in practical terms, the animation doesn't happen at all. Setting time offset to a negative value causes the animation to begin before the first frame of the clip. In this case, time offset's effect is not as straightforward. For example, if set to negative 0.5, the animation will be 1/4 of the way through when the clip begins. But shouldn't it be halfway through? If timescale were set to 1.0, then yes, it would be halfway through. But because timescale is set to 0.5, which means the animation is running at half speed, the animation is only 1/4 of the way through at the start of the clip. 0.5 divided by 2 equals 0.25, or 1/4. I'll set timescale to 0.5 since it solves the problem of the tile spinning too quickly. The same effect could also be achieved by setting scale in the scaling section to 180. Let's add easing as well. From the curve drop-down, select easing. Set in and out both to cubic. I'll set up the Anim curves modifier on the angle parameter of the other transform nodes the exact same way. The whole frame is rotating, not the tiled effect we're after. Variation in the movement of the tiles is needed so they stand out from one another. Select a transform node for the upper right tile. Place a check mark and invert in the modifier controls for the Anim curves modifier on the angle parameter. This reverses the animation, causing the tile to spin in the other direction. Set easing for out to none. For the lower right tile, place a check mark and invert. Leave easing as is. For the lower left tile, set easing for out to none. That's more like it. To change the visual appearance of the tiles as they tumble downwards, we'll use an edge detect node. Select a transform node for the upper left tile and insert an edge detect node. To dial in the effect gradually, apply a resolve parameter modifier to the blend parameter on the settings tab of the inspector. Easy. Finally, set edge width on the Controls tab to 0 to slim down the white border around the tile. Do the same for the other 3 tiles. All right, there it is. As a final touch, let's add motion blur. Select a transform node for the upper left tile. Click on Settings at the top of the inspector. Place a check mark in motion blur and set quality to 5. The same thing has to be done for the other transform nodes. That's okay to do once, but what if you decide to make a change? Then you'll have to make the same change on all the others. That gets pretty tiresome. To get around it, the motion blur and quality parameters can be published. Once published, the motion blur and quality parameters of the other transform nodes can be connected to them. So changing one changes all. Right-click on motion blur and select Publish from the menu. Do the same for quality. For each of the other transform nodes, right-click on motion blur and select Connect to Transform 1 Motion Blur. Then right-click on Quality and select Connect to Transform 1 Quality. Transform 1 is the name of the transform node containing the published parameters. Now, changing the motion blur and quality setting on any of the nodes will change them for all the others. That's looking great. All we have to do now is save our transition so it's available for use in the effects library. Click anywhere in the node editor to ensure it's activated. Press Command-A, Control-A in Windows to select all the nodes. Right-click on a node and select Macro, Create Macro from the menu. Give the transition a name at the top of the dialog. This is the name that will appear in the effects library. When this transition is applied in the Edit page, the inspector will by default have a duration parameter that can be adjusted. That's all that's needed for this transition. It is possible, however, to expose other parameters so they're available in the inspector. To demonstrate, we'll expose the edge width parameter of the first edge detect node. This is the one for the upper left tile. To do that, search for edge detect 1 in the list of nodes. Expand it. Under the Controls section, put a check mark in edge width. This parameter will now be available in the inspector on the Edit page. To save the transition, click the Close button. Click Yes. To have this appear in the Fusion Transitions category in the Effects library, save it to one of the following locations. I'm on a Mac, so I can verify that that path is correct. I cannot verify for Windows or Linux, but these are the locations listed in the reference manual. Also on my system, I had to create the last two folders myself, so you may have to do the same. Click Save. Let's go to the Edit page and use our new transition. Open the Effects library. Select Video Transitions. Our transition should be in the Fusion Transitions subcategory. There it is. If you don't see it, shut down Resolve and restart it. It previews just like the other transitions. Let's apply it to an edit point. We can adjust its length and the animation adjusts automatically. If we open the inspector when the transition is selected, we can see the controls for it in the Transition tab. There's the edge width parameter we exposed. I'll turn it up. This will only affect the upper left tile. Super! A tutorial about transitions would not be complete without mentioning the Dissolve node. It has background and foreground inputs for connecting the outgoing and incoming nodes. All you have to do is apply a Resolve parameter modifier to the background-foreground parameter in the inspector. This node is invaluable in creating many types of transitions. And there you have it, a primer on creating transitions. Have fun creating your own. Thank you for watching.